Hello Year 11 and welcome to our next extension video here, exercise 1G, solving quadratic equations. Now these do have interesting practical applications. They can be, kind of, well, you could say hard, you could say interesting to solve here. So let's have a look here at question 11a, if I could. Now, we've got these worded problems. It certainly makes life more interesting. I've got a rectangular area. It can be completely tiled with 200 square tiles. So, 200 of my tiles fills the area. If I increase each tile side by 1 centimetre, square tiles, then I will only take 128 tiles. How big are those original tiles? How curious. Well, let's draw a little picture. Right, let's say this is my tile. Right, that's x by x, and that's x squared. 200 of those are going to fill my area. If I were to increase this by 1, right, then my tile would now be this big. Right, that would be x plus 1. X plus 1 all squared, so it's going to be x squared plus 1 squared plus this is going to be 1x, another 1x. So x squared plus 2x plus 1. It's going to be my new tile. So, I know that. Let's write these things down. 200x squared. Right, my original tile side is going to be x. 200x squared is the area of the place that I'm tiling. And that's also equal to 128 of x plus 1, all squared. Okay, 200 of my small tiles equals 128 of my bigger tiles. Let's expand this out. 200x squared equals, now we're going to do two of these at once. Square this, x squared. 128x squared. Add these two things together, I get x. Sorry, multiply them together and multiply it by 2. Multiply those together, I get x. Multiply it by 2, I get 2x. 2x times my 128 plus 256x. Square that one is 1 times this. Plus 128. Okay, so 200x squared equals 128x squared plus 256x plus 128. Okay. Now, we can rearrange this. You can see we're going to have a quadratic. Let's drag everything over to the left, and I get 200 minus 128x squared, 72. 72x squared minus 256x minus 128 equals 0. Gee, 72 times 128, that's going to be pretty hard, but look, I can see these things. I know that there is a nice big common factor that I could divide all of those things by. I know that 256 and 128 are powers of 2, and 72 is 9/8, so I can divide all of these things by 8, outside of 9x minus 32, x minus 16 equals 0. And I can divide both sides by 8, 0 divided by 8, right? I can divide 0 by things I can't divide by 0. 0 divided by 8 is still 0. So in fact, when we get a common factor with a quadratic, you just take it out and throw it away as such. So now we're down to 9x, oops, there should be a squared there, 9x squared minus 32x minus 16 equals 0. Still fairly tricky. Let's have a look. Product sum factors. Alright, we've got a non-modic quadratic here. My product is 9 by negative 16. 9 16s are the same as 2 lots of 9 times 8, which would be 72, is 144. So my product is negative 144. My sum is negative 32. Now, because they're both negative, I know that I've got a positive and a negative factor. They've got a difference of 32. Right, I need numbers that multiply to give me to 144 with a difference of 32. Right, if I it won't take me terribly long to work through a couple of factor pairs. So 2 72s, no. 3 lots of 42, no. 4 lots of 36 is 144. Okay, so my factors are negative 36 and plus 4. Okay, there's my factors. So now let's put them in over here. 9x squared minus 36x plus 4x minus 16 equals 0. Right, well, here we've got 9x outside of x minus 4 plus 4 outside of x minus 4 equals 0. I get 9x plus 4 x minus 4 equals 0. Now that tells me that either x equals minus 4 over 9 or x equals 4. I can't have tiles with a negative side length, and certainly they wouldn't be covering the area. Now, if I squared that number, if I said I had tiles with a side length of negative 4 over 9, then the area, side times side, would become positive. You multiply two negatives, you get a positive number. But no, that is not what we are looking at here. This is not a reasonable answer, so my tiles have a length of 4. Okay, so therefore, tiles have a side length of 4 centimeters. Okay, and that's good enough for your answer, but just a little bit of explanation here, just a bit of confirmation. Are we happy with this? Let's have a look. If I've got tiles that were 4 by 4, my area would be 16. 200 times 16 is 3,200 square centimeters. Now, if I've got bigger tiles that were 5, my pen's going funny, 5 by 5 with an area of 25 square centimeters each, 128 times 25, if I could, is 3,200 square centimeters. Okay, so there we go. We generated a quadratic and we solved it to get an answer to a moderately practical problem. Okay, they're tough, right? But you're smart people. Check that out. Have a look at some of the others, right? And shoot me a question. If you find one interesting, not quite sure what to do, or you get something that seems implausible, let me know. We'll talk about it. Okay, good luck.